Bismillahirrahmanirrahim. Hello students, how are you? Okay, good news is that in this session we will finish chapter 1. And also I have to say that I have published the PDF file on the website Darsa. So it's possible for you to access to the PDF file now. Well, okay, good. Let me change the PDF file here. It's not the newest one. Well, I'm still waiting for the PDF file. It has been uploaded, but I'm waiting to see it. So we had a discussion about different types of distributed systems, I think. We talked about distributed computing systems, and also we named cluster systems and grid computing systems. And yes, it's the file. So let me slide. Yes, cluster computing, we talked about it a lot. And also grid computing, the architecture of the grid. And now, the other one is about distributed information systems. It is also called transaction systems in business. So if you have passed database course, I'm sure that you are familiar with these types of systems, transaction systems. No sound? Can you hear me? Mrs. Marvel said no sound. Can you hear me, students? Yes, okay. Very good. Okay. So, as I said, distributed information systems is another type of distributed systems, or popular distributed systems indeed. It's about transaction, and probably you know that a transaction is a collection of operations on the state of an object. Usually this object is database, but we can have the other objects such as object composition, and in this manner it satisfies the following four properties. These four properties is called acid properties. It's not about acid, in fact, but the first letter of each property can combine a word, can create a word acid to make it easier to memorize it. The first property is about being atomic. To the outside world, the transaction happens indivisibly. It means you cannot divide the transaction, you cannot break it into two or more sections. For example, suppose you want to transfer money between your accounts. You are using online banking, and when you click on for example, do transaction, the transaction is moving, the act of moving money from your account to another account. Okay, so atomic property says that this transaction should be completed or should be failed. There wouldn't be another state. It means it's not possible that half of this transaction is committed and the other half is failed. It's not possible. The complete money will be transferred or nothing will do. It is the meaning of atomic. Is it clear? Why we say atomic? Why we say atomic? Why we use this name for this property, atomic? Because in our world, atom is the smallest part of everything. We cannot divide it into two or more parts. Okay, so we say that transactions are atomic. Have you passed database course? I asked you, have you passed database course? Do you have it in your bachelor? Database. Very good. So, okay. So it's easy for you. The other property is about being consistent. The transaction does not violate system invariance. It means before a transaction starts, the database is in a consistent state. After the transaction is completed, the database again still must be in consistent state. It is the meaning of consistency. And isolated means when we have some concurrent transactions, some transactions to modify a database. They want to access to the database at the same time, simultaneously, concurrent. Okay, so we can serialize these transactions. It means we can create a queue for this transaction. Do you know the meaning of queue? SAF. We can have a queue, and for example, the transaction 1 at the first time must be executed, and then after it transaction 3, and then transaction 2, and so on. All the transactions are concurrent, but it is possible for us to make this queue. It's the meaning of isolation. And the last one is about durability. Durability means once the transaction commits, it means once this transaction completed successfully, the changes are permanent. The changes are permanent. The database, when you change the database, these changes would be permanent. It's durability. Is it large enough? What is large? What do you mean? What? Miss Zoha, what do you mean? Is it large enough? What are you talking about? About picture? Do you have problem? Do you have problem with this picture, with the shared PDF file? Can't you see it correctly? I don't have any problem with this picture. It's large enough for me. But I don't know if you can see it correctly or not. I'm talking about the shared PDF file. Can you see it correctly? Yes, okay. Well, sometimes we have some completed or complex transactions. It means some transactions are nested, and I don't know what's the meaning of nested in Arabic, but it means some transactions may have other transactions, may contain some other transactions. Like nested for loops. It means a loop that contains two or more loops in it. We have the same condition in transactions too. These complex transactions needs to be processed, and when we have decentralized data, it means our data is distributed between servers, two or more servers. Then a transaction wants to access to all the servers in the correct time. In this situation, we need a TP monitor. As you can see, TP monitor. This TP monitor is responsible to handle these types of complex transactions. A teleprocessing or TP monitor is a control program that monitors the transfer of data, between multiple local and remote terminals to ensure that the transaction processes completely, or if an error occurs, to take appropriate actions. It is the duty of TP monitor or teleprocessing monitor. Got it? More explanation. Okay. In a simple situation, suppose that we have one server and our database entirely is stored on this server. Okay. So all the transactions to modify the database is going to this server. It's easy. But in the more complicated situation, our data is decentralized. It means we have only one database, but we save and we store each table of the database on a different server. In this picture, we have 3 servers. Each server is responsible to store a table of our database. So the collection of these tables makes our database. In this situation, when we have a transaction, this transaction wants to modify some data. And as I said, each table is stored on different servers. So these transactions must access to different servers. We have only one transaction, but we need to access different servers. In this situation, we need TP monitor, teleprocessing monitor. And I said to you that it is a control program that monitors the transfer of data between multiple local and remote terminals. Clear? Good. Why do we use decentralized data? I said when we use decentralized data, distributed data, we need TP monitor. But why? Why do we use decentralized data? Why we distribute data in different servers? Please note that these servers is not copy of each other. They store a different data. Exactly, because we want to prevent bottleneck. We want to prevent bottleneck and also to increase the security, and so we use decentralized data. Okay, very good, very good. In enterprise application integration, we're talking about distributed information systems still. We said that TP monitor can monitor and control transferring data between multiple terminals, but it doesn't separate applications from their databases. Also, needed are facilities or direct communication between applications. So we have some requirements such as remote procedure calls. Remote procedure calls, or RPC in short, is to call a procedure remotely. The name is clear. For example, have you used the remote desktop? It means have you connected to another computer, to another desktop of computer, and control the mouse on that machine? Yes, by network. For example, you are in the local network and you want to connect to the desktop of a different machine from your machine. Okay, so you connect remotely to the desktop. It is an example of remote procedure call. It means that you call a procedure on the destination machine. Okay, you call a procedure on the destination machine, and it is executed for you. Another example, suppose we have a network, a local network, and we have a shared printer. This printer definitely is connected and installed on a machine. We have a computer that we have installed this printer, the driver of this printer, and the printer is connected to this computer. But this computer is connected through a network, and the printer is shared between some users. So when you want to print a document, you call a procedure on the computer that is connected to the printer. You call a procedure in the computer that is connected to the printer, and then you send your document to be printed. It is remote procedure call. The name is clear. The other one is remote method invocation. Remote method invocation, or RMI in short. It is exactly the same as RPC, but in object-oriented environment. Object-oriented environment. An example of RMI is Java API. Java is object-oriented programming environment. So in this environment, we have RMI. And lastly, message-oriented middleware. Message-oriented middleware, or MOM. It is based on message passing or message sending. Different things can create some messages and send them to other computers or other machines. Why do we use these methods, RPC, RMI, or MOM, to connect applications in distributed system? To connect some applications in distributed system. This is Marvis says, I'm in Iran and I have a problem with the internet. I cannot hear your voice. So I don't know, what should I do? One you can do is that after the class finished, you can log in again to the Darsa website and go to recorded sessions, and then you can use the recorded file. Well, okay, we talked about distributed computing systems and also distributed information systems, and the last type of distributed systems is about distributed pervasive systems. Pervasive means فراگیر in Farsi, but we can say جامع in Arabic, probably, I don't know. It's about some systems that are usually in use, vastly in use by people, and it is also called embedded systems too. Embedded systems means تعدیه شده systems that are embedded in another systems. Let me give you some examples. Pervasive systems or embedded systems usually use with battery or some limited power resources, and also they connect to the network wirelessly, not by wireless connection. And also they are usually, not often, they are usually small in terms of size, and they are mobile. Mobile means sayyar. They are mobile. An example of distributed pervasive systems are your mobile phones. Your mobile phones is not only a phone. It's not only a phone. It's nowadays it is a computer. You know, it's a computer, and it's a pervasive system or embedded system. What are requirements for pervasive systems? Contextual change. The system is part of an environment in which change should be immediately accounted for. Ad hoc composition. Each node may be used in very different ways, and sharing is the default. The last requirement is important. Sharing is the default. For example, when you want to connect your mobile phone to the network, it's very easy for you because it's the default property for your mobile phone. You just need to turn your mobile phone on. It is automatically connected to the network. Is it clear for you? Is it easy? Thank you, Ms. Rasha. No. Let me give you more explanation. We talked about different types of distributed systems. The first type was distributed computing system. We talked about cluster computing and grid computing. And then the other type of distributed system we talked about was about distributed information systems. They are based on transactions, like online banking. Okay, online banking is a distributed system that we use transactions to modify databases. So the third type and the last type of distributed systems are called pervasive. Pervasive systems are those systems that in the system nodes or machines are small, mobile, and often embedded in a larger system. For example, in last years, our TVs, our televisions, was only television, no more thing, okay? But now, in modern televisions, we have some facilities to connect to the internet. So our television is a computer now. When this television is connected to the internet, it is a machine, it is a computer, it is a node in our distributed system. This type of distributed system is called pervasive systems or embedded systems. We have the same situation for our mobile phones. Okay, It's not difficult. It's easy, really, it's easy. Good. Here you can see some example of distributed pervasive systems. TV, smartphone, PDA, tablets. These are home systems. Also about electronic health systems, or EHS. EHS, electronic health systems. And also sensor networks. These are examples of pervasive systems. Home systems are clear. I talked about it. But what about electronic health systems? Look at this picture. Sometimes we have some systems to monitor and control health information of a patient. For example, we have a sensor to calculate the level of diabetes, and also we can have some sensors to monitor blood pressure, and these sensors are installed on the body of patient or ill people. So these sensors repeatedly collect information and data and send it to a server, to a master. So if the condition of the patient, the ill people, changed suddenly, then doctors will be informed. It is healthcare systems, and it is a type of pervasive systems. Clear? How about other students? Good. So in healthcare systems, what is the main goal? Why do we use healthcare system? Why do we use healthcare systems? What's the main goal of using such system? Okay, for the health provider to have information about the patient. Okay, I know. To make easy for determine the problem. Okay, why do we use this system? What's the main goal? The main goal is to prevent that we stay the patient in the hospital. By using such system, the patient can go to home, can do his works, his jobs, and routine day, can have routine day, okay? So it's the main goal to use healthcare systems. We don't want to stay patient in the hospital. So we use some sensors to monitor his health conditions, and then the patient can go home. That's easy. No, I said what's the main goal. The main goal of using healthcare systems is that the patient can go home and do his routine jobs. There is no need to stay him in the hospital because we can monitor his health conditions when he is in his home. Got it? Very good. So, when this is our main goal, we must keep in mind that healthcare systems must be easy to install. Must be easy to install. It must not annoy the patient. It must not annoy the patient. Can you understand me, what I am saying? It must be rahat. Rahat. Okay? Comfortable. The healthcare and the sensors must be comfortable for the patient. So the patient can do his job easily. Yes, yes. غير مزعج. Yes. غير مزاحم. Okay? لا مزاحم. Very good. So, is the مزاحم another word with the same meaning? مزعج and مزاحم have the same meaning? Yes? Yes. Good. So it is another type of pervasive systems. Again, look at this slide. We are talking about pervasive, distributed pervasive systems, home systems, electronic health systems, and sensor networks. What are sensor networks? If I want to give you a good example about sensor networks, I can say that assume, yes, it's a good example of sensor networks. Consider in a forest, a large number of sensors are installed in different places. The purpose of these sensors or this sensor network is to monitor and track the movement of animals in the forest. These sensors transfer data wirelessly, so we can collect the data and we can have some good information about the places that animals move there. Got it? Was it clear? Was the example clear for you? Again, please. Okay. Do you know the meaning of sensor? Do you know what is sensor? What is sensor? Sensor is usually a small hardware. It is a small hardware that can collect some data. For example, uh, elevator has a sensor. When you put your hand between the door of the elevator, it is not closed because the sensor can detect your hand and the door is not closed and the elevator is not start. Okay, it's a sensor. It's a type of sensor. So assume in a forest, in a jungle, a large number of sensors. We install a large number of sensors in different places in this jungle, in this forest. Okay, and the goal of this sensor network is to monitor and track the movement of animals in the forest. Movement of animals in the forest. To monitor, to see that in which places animals often go. Okay. So these sensors transfer data and they are connected to a server wirelessly. It is a sensor network. It means we have a network of many sensors here. Got it, Miss Rasha? Very good, thank you, you're welcome. Characteristic of sensor networks. The nodes to which sensors are attached are many, tens of, hundreds of, or even thousands of sensors we have. It's simple, small memory compute communication capacity. And sensors often use with battery power. We don't have electricity power in forest. So the sensors must be worked with battery. The organizing of sensor networks are done in mainly two categories. In the first organization, we have our sensors, and all the sensors only transfer data to the master, to the site. Okay, such as our example. In our example, we had many sensors in the forest, and the sensors only transmit or only transfer data to the server. In the second organization, sensors can have some facilities to store data and to calculate something. Oh my God. I think my connection to the server is poor. So I must wait. I have to wait to... Can you hear me now? Yes, it's now. Yeah, the connection is green now. The connection is green now. Okay, okay, okay. Let me continue. I talked about the organization and organizing sensor networks. Okay, I said that we can organize our sensor networks in two main ways. The first way is that our sensors are responsible only to send data. There are some sensors, and the duty of sensors are sending and transferring data to the server. Okay. In other solution, we can organize our sensor networks in such a way that our sensors can process and store data. It means each sensor is a small computer. Each sensor can be a small computer. So each sensor is able to calculate and process data and store it. And then it can send the result to the operator's side. So we can organize our sensor networks in these two types. Can you give me another example of sensor networks? Another example of sensor networks. Teeny database. No, okay, it's good. But one another good example of sensor networks is about traffic monitoring. Traffic monitoring. We can use many sensors in different streets in a city. Different streets in a city. And monitor the amount of traffic jam, such as monitoring animals' movement in forests. We can monitor cars traffic in streets of a city. Okay? Good. Congratulations, we have finished chapter 1 right now, and I can say that I have uploaded the PDF file on the Darsa website, so you can download it and you can review it. And now we can start chapter 2. well. But before I start chapter 2, I want to ask you a question. We have 26 students here, and I want to ask you if there is any student in this class who every day reads دعای عهد. I want to know if there is any student in this class that can read this dua every day. Really? Very good, very good. Thank you. Thank you. I highly recommend you, I strongly recommend you to read it, to read this beautiful dua. Really. And I can assure you that your life will be changed. Oh, again, my connection is poor. Okay. So, let me start the next chapter now. So, I am going to upload the PDF file of chapter 2. Really? Are you tired? We have time to start chapter 2 right now. Miss Ezal said, can you stop here and what about other students? Are you tired? Do you want to finish? No voice? Why no voice? It's awful, really, it's awful. Very bad. Can you hear me now? Can you hear my voice? Yes, okay. I said that I'm not sure about the pronunciation of your names, so please excuse me if I wrongly pronounce your names. I try to correctly pronounce it, but I'm not sure about it. For example, I'm not sure it's Ezal or Azel, but so please excuse me if I wrongly pronounce your name. Well, we have an awful night today, and Azel, okay. And what's the meaning of Azel? What's the meaning of Azel? Does it have meaning, or it's just a name? Azan. Oh, okay, I got it, Okay, good, very nice. Well, in chapter 2, we want to talk about architectures. So, yes, I know. I got it. Azal. Okay. Azal and Abad. Okay. And it's very beautiful. It's very nice. Okay. So, we have come from Azal here in this word. Our God, Allah, has created the soul of all of us in Azal. And we promise to worship Him, only worship Him in Azal. And then we came to this world. Okay. So, okay, we will stop our lecture here, and we will continue chapter 2 in the next session. But as you can see, here is a dua, and this is a dua. Can you guess? Don't search it, please. Don't search it. Okay? Can you guess who said this dua? رَبَّنَا أَفْرِغْ عَلَيْنَا صَبْرًا وَتَوَفَّنَا مُسْلِمِينَ. Who said this dua? Please don't search on the internet. I want to find that if you can guess who said this dua. Ibrahim alayhi salam. No. It's not from Ibrahim, Prophet Ibrahim. No. Guess. Do not search it. Do not Google it. Do not. Just guess. It's amazing. Really, it's amazing. It is in A'raf, Surah A'raf. But you will be surprised if I say that yes, exactly. It's not about Musa alayhi salam, but it is related to him. It is related to him. And you will be surprised if I say that wizards of the time of Musa alayhi salam said this. Wizards, magicians, wizards. Wizards when saw the truth, they believed in him and in his God. And yes, as-sahra, sahir, yeah, exactly. And when wizards saw the truth, they believed in Musa and in his God. And Pharaoh threatened them that he will cut his hands and his legs, but they stayed in his belief. They stayed in his belief and said this dua. It's very good. I recommend you to memorize this, and you can say in your qunut, in your prayer, when you in your qunut of your salah. And it's a very good dua, I think. And you know, our God recommended us to be patient in different parts of Quran. Sabr, patient, okay, patience. And you can ask yourselves if you are a patient people or not. And have you tried to practice to be patient? I'm sure if we practice, we can. And it's very important for us because our God asked us to be patient. You can complete this ayah. Inna Allaha ma'a, complete it. Yes, Inna Allaha ma'a as-sabirin. Or وَتَوَاصَوْا بِالْحَقِّ وَتَوَاصَوْا بِالصَّبْرِ. Yeah, sabr. It's very important. Try to practice to be patient. And okay, that's good for tonight. And I hope you enjoy this session. We will continue our lesson next session about